Hi, hello everyone. It's Ali back here, and welcome to my stream. We are at season 3, episode 13, I think already. Yes, and this is the third episode in a row which has exactly the same naming because we're gonna be doing exactly the same thing. So um, today, yeah, let me quickly remind you, as usual, what we're building here on these streams, and especially this season right now is we are building options derivatives options trading strategy, especially strategy that called wheel. So what we started with is we created market simulation engine which allows us to simulate different kind of markets like bull runs, bear market, calm market, high volatility, sideways markets. You can tune all the way you want, and then you can also choose different presets for the strategies like conservative, moderate, aggressive, or active. And it's having different rules and parameters based on this preset, or you can like define anything you want yourself. And then we are testing it, we are simulating it, because this market simulation allows us to create tons of different variations of the price charts that could have happened in reality. So we test statistically how our strategy performs statistically. So we have like win rate and mean APR, mean maximum drawdown, and so on. So what we were doing for the last 3 episodes, and this is gonna be the fourth one, is we are done with all this setup. And initially I thought I'm gonna be testing different parameters and different markets manually, but then I realized that it doesn't make sense. So I turned to my friend AI, and it helped me to implement like come up with a couple of so basically we are doing here a research which is like tons of different experiments with different parameters. We are doing it just a permutations. We are seeing how the strategy performs statistically on different presets or different values of the parameters. And based on that we do the assumptions like which markets are the best for the strategy, which are not, uh, how to deploy capital, where, when, and so on and so on. So we've performed so far already 13 of them, and we still have few of them to go. We have the high severity, medium severity, and low severity left here. We used to have critical ones as well. So the high and medium, this is what I'm aiming for today. I hope we are gonna make it in time and implement those. Maybe there will gonna be new ones here coming up, maybe not. they might be rearranged somehow meanwhile, and so on. So yeah, if we will manage to implement all the experiments and nothing will be left, then we are gonna go to the next thing in our list, our to-do list, and it's basically, yeah, a couple of, you remember from the last episode. If you don't, you can look at it, and I'm gonna be covering that today again. Let me do that later, and we can start right away, right now, with the new experiment. See, we're at it already, and yeah, we have this template here that we're just copy pasting every time. Um, so let's run a new session of Opus, and going to hell here. Okay, start our new session of Opus. I'm at 15% usage right now, 15.2, so it's gonna be fine today. I'm just doing some small experiments meanwhile with that, and yeah, let's go ahead and do this right away now. And while I'm gonna be preparing the plan, I'm gonna be refreshing my memory. Oh, it's faster now. Refreshing my memory on what was done last time and what we're gonna be doing now. So the last time we finished with I think so let's take a look at the commits that I've done. Experiment 8, 9, 10, 11, 12, 13. We've done like 6 experiments last time. Wow. Let's do that as well. We are now faster. Also, we will be implementing the multi-threaded simulations now, and they supposed to run faster, and also AI seems to. So case for games, all guys properly, and we've done from 8 VRP sensitivity analysis, model robustness analysis, look back cycle interaction, has threshold testing. What we have ahead of us today is the deployment signal estimation. Oh, that was framework has established drift floors, ERP floor, OU dynamics requirement, IV/RV autocorrelation, active only for multi-year, cost resilience at any realistic friction. In practice, these additions must be estimated from trailing market data. Focus on active deployment signal since it's the only multi-year viable and cost-immune strategy. Test A, trailing windows, 30, 60, 90 days annualized return as drift estimators. Note that active is a drift immune, so drift signal is secondary, only relevant, moderate, and conservative tacticals. And B is trailing IV/RV spread, 20 days, 40 days, 60 days as VRP estimators. Because VRP more than or equal than 10% required. And the C is IV/RV correlation at leg 1 utility clustering detector. I don't know what does it mean. The next one is a combined signal deploy active versus pause. Okay, so this is probably what I was heading to, and it was actually implied here by all the experiments. So let's yeah, let's see how it's gonna work out. Preparing a plan now. I'm gonna review it. If it doesn't have any changes in the engine, then I don't actually have to review it much and let it. So I thought I was telling you that I'm training slowly this strategy manually. They I actually onboarded you like I sold another put option but with different strike price. So I'm right now currently holding two different options, and I think one of the tests here is actually about that, doing that. But our strategy by default is not right now. We might we might do this. I definitely see it's a cool thing because you can have like um high delta puts and low delta puts together, and then like you have both of them. In case you win, you get more. In case you lose, you lose less. It's like you're diversifying. So you can like change the assignment level, but yeah, well, I guess we're gonna get to that. Market went down today because of the US employment uh report, I guess. Yeah, not that fast. Our favorite thing to check the status of all operational operations. OpenAI also operational today. Good guys. Okay, finally the plan here. Okay, plan. Let's take a look quickly if it's changing anything. Okay, yes, it does. It does. Then we need to do the plan. So yeah, that's what I thought. It actually, I think. Yeah. So the phase one is to create the no trailing return computer trailing via ACF1. Boy, okay, okay, that's what we are worth. I remember I was about to ask it to do this actually. Now it's I wanted to ask like, okay, we came up with all these experiments now. Can we incorporate that into strategy so it like automatically detects no, I should not deploy now here. So when you run this simulation, it's actually like um always basically earning money because like it just doesn't work when uh, in the market that's not suitable, and it's always working or like enabled in the market that's suitable. That's okay. There are gonna be tests, of course. Okay, this will take time, but it makes sense. Go. So there is a trailing annualized return. There is a mean of IV RV trends. Lag one autocorrelation. Compute ICF1, the IV-RV ratios. So pure decision function turns true if all enabled. Repeated signals. Okay, from looking at it, I'm thinking it's probably requiring another um round of factoring after I put it another round ring for production. In you know, it's have to like show more stuff here now. Everything market is good. I'm selling puts. Okay, fine. Probably it's gonna have problems, you know, because they're gonna be running the multi-threaded now. Oh, coding. No. Okay, finally we are running our multi-threaded simulator. No, it's not multi. What's happening? I don't know, should I stop this process running? Yeah, the task. Make it multi-thread. First one is definitely. Okay, we are halfway there. Um, take a look at some. Meanwhile, was a new GPT 5.4 release. Okay, maybe ranking here already. Yeah, okay. On par with the Gemini 3.1 Pro. Um, 5.4. I think it's only available through the API. Probably it's not even in the codex. Let's check. One more time. Okay, so it's available as a 5.4 here. It works. Latencies. Price is big. Looking at this, I'm expecting some. Okay, guys, so what's in here? We just keep running in a loop here. At least it's for free. My usage is not increasing. It keeps checking. Let it be. Yeah, the process is take. Build them. We will. what's cool here is that, let's go back to the models. That you can see that this, I think the only but if we go to, yeah, it's taking too long. Last forever. Some of you may say that I should start this new, but yes, getting rusty more and more. Maybe this is time for me to learn it actually. I would definitely factor it first as a clear architecture. Let's see who's gonna be first. Tentacle, red or doing a new version here. I might as well keep this one running and see what's gonna be faster. Okay, 70%. So for 10% it was still. 75 already. Yeah, it's very writing the 80% with the old script. Yeah, it's taking so long. I don't know if we're gonna be in time today to implement all the experience. What the fuck? You already planned all that. Why is it so, like two huge reasonings just to do what? I wonder how long will that one take run. This one's running for current one running for 22 minutes already. Experiment number 14 is running for 22 fucking minutes. That okay. I have like 10 cores or something. Times faster. Find out. While our already not faster than the core. Team Saga. Going there. This is what we've built on the first episode. Like a pilot project for me. For the stream. Okay, finally it's what 2-8 start. And it's down already. Down. Our main one is almost finished after 30 minutes. still cannot run the multi-threaded version. First one is done already. Yeah, I'm gonna fix. Oh, there is something else running. We still have time to outperform it. The multi-threaded approach. But it's still not running. And it's still. Imagine there was an error here. It will figure out that it just was running useless stuff. But this AI developers, data scientists. Okay, first one. Experiment D is running now. Oh my god, it's 288. It's gonna it's gonna last 1 hour. This is like a crazy ass experiment. I don't even know what it does. So much time. Okay, hopefully outperform. Want to go that maybe? Means that it's working now. We were halfway on experiment B, one that took us 20 minutes. Remember, the struggle started at exactly the half. My processor is 100% overloaded now. Probably you even see the problems with. It's supposed to be 8 times faster now. Already at 60. Running here. It will be interesting to game. Okay, guys, this episode is about looking at the loading. And normal water and empty. Okay. Okay, I'm going awake you one of the version. Reddit version is already hating myself for not using Python or Rust. Could have known, you know. Now we know. TypeScript typing, but we actually didn't write even a line of code here. Started this whole project in Rust. Maybe we should do. It was my dream to actually something in Rust, and the programming itself is dying now, and I didn't even have a chance to try Rust manually. So maybe I'm gonna try AI at least. It's already past 9. This one is gonna be stuck for sure, because it's now coming to the 5 years calculations, and 1903. One is done, starting now, and I think it's one running for, actually one already running for 40 minutes, almost outperforming it already. Luckily, it just all crazy episode. I didn't. Yes, we have some unexpectancies. Okay, so the experiment D started already, and now we are like at the same. One is at 52%, still at 150. Then be right, way behind. One is still at 150. One is at 05 already. Credit is at 155. The model managed to code or think and code for the 30 minutes, then produce a credit version, and now running, and it's already, I think, almost outperforming the one threaded version. or maybe not much left here. Results. D is the credit one is already. Oh, now we have them both. Taking a long time, even like this. One who's watching. I was thinking actually to create a shortcuts, but like highlights of my videos, because especially I want to do it with AI. There is a lot of moments when we just wait like this, don't talk or something. And of course, for the live stream, there is like no way to do this. But for the recordings, I think for the Telegram or for the channel, better way can subscribe to this shorter than hours. Episode could 20 minutes. I don't know. I didn't try, but this is my guess. And yeah, that should be it here for people. Some people, they open my channel and they hour long. My friend told me that actually. Go to hour long video. Spend my whole life watching. Yeah. And by the way, for those who are watching this time, this is a Gemini app, Gemini model, which has a tool to download transcriptions from the videos, and it can help you actually to navigate through my videos, find you like the important moments with time codes, or like just shorting it in general. It works immediately. Downloads text from you, already has it, so it doesn't cost anything. It doesn't even wait. It's how I was doing my videos before I stopped doing that. I might as well start doing it. I'm working a lot agentic automation of my life in parallel. So this is of course part of it, planned, not that prioritized. Unfortunately, I'm planning to do this automation. Uh, yeah, already started a couple of times. At first, NA10 workflow, then I re-input own based on old agent, I think. But it was all, I don't know, much. But now I'm using OpenClaw for a month already, and yeah, different. And to life. And this was gonna be a part of it. Once I'm gonna get to it. I have some stuff to work on. That's one. 95% already. The first one is running at 50 minutes already. Second one is running 18 minutes after being developed for 30 minutes. A 97%, 100%. Finally, the last one. Come on. Come on. Okay, it's done. Okay. Okay, empty version is done. You can compare with what's already available. Full threaded. That's not great. Finish. Right. So it took around 18 or 19 minutes run for the multi-threaded version. That's a lot. I bet Rust could have done this. Okay, so it started summarizing here. Maybe this will help get a better result, or I hope so. Closing. I don't know, probably we should wait for this one. Run. I'm tired of it. Still have 40 minutes. Might able, I don't know, depending on what the other experiments are, we might close some. Go ahead and read it finally. Okay, experiment 14, deployment signal estimation. Um, wasn't it summarizing? Okay, this is setup of parameters at height. So the key findings. Deployment signal does not improve performance. Okay. Only 1 out of 210 signal combos, 0.5% achieve positive sharp. Sharp across all signal types is the existing regime filter is sufficient and strictly better than any additional deployment layer. ERP estimation noise fundamental notifications captures. ACF guard is structurally compatible with OU dynamics. It's gonna be OU has a fair market. OU processes at realistic K values produce ACF. Okay, these measurements can drop the normal version. The regime filter is already the deployment. Active all-weather property makes the estimation like code margin. The conclusion is no deployment signal added to the framework. The existing filter already provides the optimal deployment decision at the correct granularity, trade, not per day, adding VRP threshold for safeguards, stop remove profitable trades without imp. Okay. No remaining experiments block live deployment. Experiment 14 blocker. Work is station. We have keep order of. Are you doing it like this? Okay, so the readme said here that deployment signal confirmed. Provides deployment. Appeared here. Initializing the here adaptive here. Wanna be okay, since a new signals not need, we keep them or remove. For committing this experiment. Okay, click also remove simple okay, the whole experiment was say that we had a result. Remove that. It read me that we have Uh, yeah. So that was huge one. Expectedly. So let's do the rest. Let's do 15. Fuck it, we are on it. Oh, oh. Make sure to sweet. I don't see. Only and like this have been that it's same as one basically. Okay. And I think it's gonna be very quickly executed. Much. Or 1,000 rated workers. Experiment 4 was running 20 minutes, expecting it. Okay, we are running it now. Already stop. Start again. Getting too long. Even running. No! Fuck. It's a doesn't work. And wait. Should start. So it's an issue with terminal, I think. Yeah, totally. Why? What is happening? Running now. They're here at 51%. Already. Probably that's gonna be the last one today. Then 5. Was quite fast. More permutations than it used previous experiment. Okay, done. So let's pop this one and check the results. I have the whole self in. Crazy day. Funny and waiting for a compaction now, so I need to literally finish at 5. Each dips below to sun. Okay. So the analysis is ready. Take a look at it. Findings is that active has no practical volatility. Any tested horizon. Max drawdown. Saturation straightens at a higher volatility. Drift immunity survives 5-year bear market at all volatility levels. Regime filter is universally beneficial. PRP 10% for holds at 5-year all volatility levels. GBM gap is stable at all volatility levels. Sharp decay is proportional to volatility. And the conservative moderate confirmed not viable at 5 years. Conclusion is active's multi-year viability extends to 100% volatility with no practical ceiling. Active maintains positive sharp at every test volatility and horizon combination. Max drawdown, saturation straightening at higher volatility. Drift immunity price 5-year bear market at levels division. uh, all combinations. Test. Okay. Implement and just guidance extended. Table at a implement was 12 fusion. Okay, so the last part, to rearrange the rest of the experiments or add the new ones, and then we will be finishing. There are no new experiments. So regrouped. Okay. Is a single remaining step that could invalidate the frame. All synth data valid. Data valid. Oh, interesting. Gonna be about the real prices. That's actually the point. So they're slowly coming. Interesting that we are yeah, I'm basically following my cloud act. So the priority within low is implicitly sorted by value. Ones were arranged. No, it's still there. They were just rewritten. There was dates. Anyone noted that experiment 15 program making real data step. 17 was updated that added terms cost at all levels over here, removing class scenario matter. 18 was updated that is straightened the 15 data. 19 motivation shifted. Volatility setting extension is moot. Remaining value is risk averse deployers. Agreement 20 updated max drop down. So okay, we are done here. Finally, we are done. And that's it. Oh, that's it for today. Unfortunately, experiment 15 or what 14 took us so long to implement, run. Crazy, but it's also a good experience for us. Next time we're gonna be smarter, faster, and more efficiently. Yeah, so we completed all the critical experiments and the high and the medium ones. This one, the only medium one that's left, it was just proposed to the high, and it's already about testing it on the real assets, real price of Ethereum. So this wanted to do anyway at some point. So we are gonna think about it On Monday, I'm gonna be back online at 3 p.m. Central European Time. Feel free to join as usual. Don't forget to put your likes, subscriptions, to Telegram channel, to Twitter, to YouTube, anything. Leave your comments if you have any questions. And we're gonna continue on Monday, and I guess we're gonna be doing this still TH data, TH price, TH options prices, probably even. So we'll see. Let me write down here like this. Next experiment is actually the back testing on the real prices. So maybe to have to or okay. So that's it, guys. That's it for today. Thank you again for joining. Thanks so much. Bye bye. See you on Monday.